Hello everyone, welcome to the second lecture of the topic, the loss of containment. And yes, um, the starting with the risk matrix, the head of matrix. So as I said, we'll actually continue doing that in the live lecture. Okay, so remember that, remind me at the live lecture. Now, we're actually talking about hazard identification and doing the hazard. Now, let's talk about risk analysis method. Okay, so what is risk? The risk analysis. So risk analysis predict the accident occurrence and its damage potential. It reduces the risk well in advance of an accident to ensure the system safety during operation. Okay, and perform based on the answers of the following question, like what are the hazards, what can go wrong and how, what are the chances, what are the consequences. Okay, very important questions. Now there are mainly two different types of risk analysis method. One is the qualitative method, another is the probabilistic or quantitative method. Okay, and as it explains, it's kind of like self-explanatory. Like the qualitative method is like give some idea based on qualitative analysis. Okay, and quantitative method is actually based on numbers. Okay, so let's learn more about these different methods. So the qualitative risk analysis predict undesirable situation for process systems to identify potential chemical or mechanical hazards. Okay, we can actually do the qualitative analysis by performing using hazard study, process hazard analysis or PHA, or failure mode and effect analysis or FMEA. Okay, so these are the tools to do the qualitative risk analysis. Quantitative risk analysis is more based on data. So to evaluate the likelihood of occurrence of the accident, to find the specific cause and consequence of potential hazards, go along with the contribution, evaluate the effectiveness of control measures and design modification of the process system, and it uses probability theory, sometimes known as probabilistic risk analysis. Okay, so since this use actually the probability theory, that's why it's also known as probabilistic risk analysis. Okay, so ETA and FTA are an example, like the tools we use to analyze cause and consequence of that incidents. So both of qualitative and quantitative also got their own pros and cons. There's some times we need qualitative analysis. For instance, we don't have any information on the hazard at all. Okay, we don't have any data. So the lack of data, if there is any lack of data, we actually go for the qualitative analysis more. But if we have abundant data set, then in most cases we actually go for the quantitative analysis. Why? Because it's based on the statistics. Okay, so it's based on the statistics. Anyways, so it's a statistical risk analysis. We also call it like the probabilistic or statistical risk analysis too. But in qualitative cases, we use like the property of the system, and then we got information, and then we also got some data. But from that data, we have to use our judgment. Okay, or if we actually make a matrix, like it's good, bad, so that kind of matrix, and from there we actually make the decision like it is good or bad. Okay, so this is about like the qualitative and the quantitative method. Now let's talk about quantitative or probabilistic risk analysis, and we'll actually go through that. So risk in quantitative risk analysis, or we actually call it QRA. Probably you heard of that before. QRA. In QRA, the risk is expressed as the function of frequency or the probability of an accident and the consequence of an accident. Okay, so the the probability risk analysis, or like the quantitative risk analysis for a process system, use the logic tree to model the cause and consequence of the incident. Fault tree analysis is a graphical representation which is used to represent the relationship of the relevant causes that can lead the incident. Okay, and event tree analysis maps the probable consequence of the incident. That means from the FTA you got more like cause. Okay, cause that lead an incident, and from ETA you will get the consequence. Okay, remember that. So that's how we can actually match the ETA and FTA, and there's a tool that's called like a bow tie method to combine these ETA and FTA. This is like more advanced studies on the QRA, but if we have time, we'll actually go through that a little bit at the next lecture. But just remember, the FTA, it's graphical representation of the relevant cases that can lead an accident. In case of ETA, event tree analysis, we calculate the probable consequence for an accident. Okay, now to calculate or to quantify the risk, we need to know one important thing, which is called the failure rate. What is failure rate? For most component fails at a certain period of time, which is called the average failure rate, and that is represented by lambda, the units of failure, faults or failure by time. Give you an example. For instance, electric bulb. Okay, so this is, for instance, an electric bulb, and there's a filament. So filament is the critical component, and the filament has its own burn in time. Okay, now for these types of processes, we have a curve. We call it actually the bathtub curve. That means like at time equal to 0, in y-axis this is failure frequency, the lambda. Okay, sorry, and y-axis this is the lambda, and at x-axis this is time. That means the path curve top, it shows that at the time equal to 0, the failure frequency of an electrical component or any kind of product or the process is higher, and the more time goes, it becomes more plateaued. Okay, and after a certain time, there is the wearing and tearing period. Okay, so this is called the burn-in time. Okay, and after that, the failure rate is also become higher. Okay, so how we can actually determine the failure rate? So for a constant failure rate, it is lambda. Okay, so for instance here the failure rate is constant. Okay, so here the constant failure rate is the lambda. Okay, so probability of the component will not fail during an interval time is exponential of minus lambda t. So the probability of failure would be 1 minus exponential of minus lambda t, right? That makes sense. Okay, so it's from 0 to 1 scale. Okay, so it's from 0 to 1 scale. For instance, this 0, this 1. So probability of not failure, if this one, then the probability of failure would be 1 minus this value. Alright, so that is how we actually calculate the probability of failure, and this term here, probability of not failure, we call it reliability. Okay, we call this reliability. So the probability of failure, or PT, is expressed by this formula. Okay, now there are some very important basic terminologies we'll actually learn now, which we will apply at our next class. Okay, which is very, very important. And the most important part is the to draw the ETA and FTA, the basic terminologies we need. This is the first is initiating event. Initiating event is an unwanted or unexpected or undesired event. For instance, like you remember the first lecture we have learned like undesirable event, like put diesel at the gasoline. Okay, so that was an unwanted or unexpected or undesirable event. Okay, for instance, like the system or equipment failure, human error, process upset, toxic flammable release. Okay, any types of these events could be initiated. Undesirable event is known as initiating event. Now there's another definition of the event. So what is event? Event is following the initiating event, termed as like it's a general terminology. Okay, so it's termed as like the precursor event, or sometimes shows sometimes are termed only as the event for the event tree. Okay, so I'll give an example and you will actually have better idea, okay, what is that event actually means. Outcome event. Outcome event is the possible effect of the series of the events. Okay, the scenarios or like the outcomes of like all these events would be known as the outcome events. Okay, so give an example. For instance, there is an overheating of the cable at your house. There is a power cable and that overheats. Okay, so overheating of the cable, what it can do, it can melt the cable, right, if the overheat continues, and it can possible effect of the fire event. It can create the fire event. Okay, now here the initiating event is this one, overheating the cable. Now the event would be this, it can melt the cable, right? But the outcome event would be possible effect is the fire. Okay, and what would be the consequence? Consequence would be if the fire starts, then the consequence would be ultimate destruction, okay, of the process. So this is how we actually term like the things. What is the initiating event, or like the outcome event? Okay. Now there are some other terminologies like the event, like the top event. What is the top event? Top event is like the unwanted event that is placed on the top of the fault tree and further analyzed to find the basic cause is known as the top event. We'll see some example and we'll actually get idea what is the top event. Okay, so remember, this is the place top in a fault tree. Basic event. The basic event, or like the basic causes that are not further developed or defined, are known as the basic events. Okay, that means the ultimate system failure, human failure, or external event. For instance, in here the basic events would be the fire event. Okay, like the effect is like, I mean, fire event and it failed due to the fire, or like we have the electric short circuit. Yeah, that's more it's like electric short circuit and there is no power at all. Okay, so that would be the basic event. That means for this cause, if you actually go through, then what is the final event you will actually get? That is the basic event. Okay, Intermediate events, so all these events are the intermediate events, which is actually known as the events, okay, any type of events. So the event in for trees can be further developed by basic events and known as the intermediate events, okay. So event tree analysis is an inductive process which maps the all possible outcomes resulting from an initiating events. Any accidental release of occurrence like a gas leakage, equipment failure, human error, or it also identifies the possible accidents or consequence arise from an initiating event. Also, like it identifies the design weakness. So during the time of process design, even before doing the implementation, the work. So during the time of process design, we actually do the event tree analysis to identify the procedural weakness of the whole system, okay. It also determines the probability of various outcome or like the final consequences the resulting from the initiating event. For instance, in here the final consequences would be the failure due to the fire or the explosion, right? So this is the give the final consequences. Event tree construction. Let's give you the idea how the event tree actually construct. For instance, we have a nuclear reactor, for instance, okay. And if you know about the nuclear reactor, that we always actually give a certain type of coolant, okay, or for instance, like a D2 or deuterium oxide or any type of actually coolant to actually put in the nuclear reactor to avoid any kind of unwanted situation. You remember the Chernobyl, what has happened, actually the failure of the coolants, okay, or it went to totally uncontrolled and disabled. That's why this incident actually happened. So there is a pump that pump the coolants in here, and for instance, in any case the pump we'll actually come with that pump later, but what's happened, the loss of coolant flow. Now this loss of coolant flow is the initiating event, okay. Remember the initiating event in here is the initiating event, the loss of coolant flow. Now what it leads, we have the first layer, safety layer, and that is high output temperature alarm. And when the alarm rises, then what we should do, operators should take the action, or it will automatic shutdown. Now what if the operator didn't take any action, or at the proper time didn't take any action, just like Chernobyl? Or what if the automatic shutdown system fails? That means these are the layer of the protection. The first layer, you can ignore the alarm. The second layer, operator didn't take any action. Third layer, the automatic shutdown didn't work. So we have a disaster, right? Okay. So these are the input of the initiating event and the safety functions. Let's do it put in the qualitative evaluation of the safety function. Remember the event tree construction, what we actually said, here, we also can actually combine the quantitative and the qualitative actions with that too, okay. Anyways, so the qualitative evaluation is it is your qualitative judgment, like success or failure, or true or false, or yes or no, to evaluate the safety function or the event consequences, okay. So for instance, initiating event, loss of coolant, success or failure. That means if success, that means if there's a loss of contained flow, there would be two decisions, like there is a alarm will raise, so there will be two decisions. Okay, now if the loss of containment, like this initiating event failure, that means there is a safety function that no affect the accident path proceedings. Okay, so automatic, there is a redundant pump, for instance. Okay, the loss of coolant flow, then the redundant pump automatically start in, and it do not have any problem. So there is two options, yes or no. It worked or didn't work. It worked, then it's fine. If it didn't work, well, then we'll go back to here again. So now the initiating event, that's success, for instance, that means there is a loss of coolant. So here the success means the loss of coolant. Okay, so what will happen? The alarm, first safety function, the alarm could raise or alarm could not. If the alarm raised, then the operator will take action, it will shut down. If the alarm do not raise, then what will happen? Then the operator should actually keep eye on the process. If you actually see that DCS or distributed control system, after like operators always actually take eye on the monitor and monitor the process. Okay, why they do that? Because if the alarm fails, then the operator should take the manual action to shut it down manually. Now there are two other options: operator shut it down, operator didn't shut it down. If the operator shut it down, then it's fine, it will not proceed. If operator didn't shut it down, then there would be the automatic shutdown at the critical point. If it went beyond the critical point, it should automatically shut down. What if this also fails? Then in that case, there will be a failure. So that's how we actually create the event tree analysis by the success and failure. Okay, so this is the example for the nuclear industry's coolant loss. You can actually do it with the gas release, for instance. Okay, so everything actually is given in here. So this is the example of our event tree construction. Okay, so what we have learned in here in this lecture? In this lecture, we have learned on different risk analysis methods. We have learned on the failure rate. We have learned the basic ideas about what are the events, which is the very important part. And we learn how to construct an event tree. And the next lecture and our last of the lecture of the loss of containment series, we'll learn more on the FTA. All right, so take care everyone, and have a good day. See you at the next class. Bye.